Yesterday we discussed box plots and how that's a visual representation of the 5-number summary. Today we're going to kind of review some things that we've already talked about and then some other things as well. Box plot yesterday, distribution of numerical data, and it's a visual display of the 5-number summary. And then we also have a bar graph that we looked at last unit. It displays counts of percentages for categorical data. Each bar represents a single group where order does not matter. Therefore, we can't make any statements about shape or trend on something like this. Just to give you an idea about the order doesn't matter, right? I can put that family column at the beginning. I can put the comedy column at the end. I can put the horror column in the middle, and the shape in which we create or that we see does not matter here because this is categorical data. Quantitative data is numerical, so that order does kind of matter. Your axes are scaled numerically. If you notice our x-axis on these, they all have numbers on them, like 50 to 90 for the first one and 55 to 85 for the second one. Going back to these, our x-axis is action, comedy, drama, family, horror. So those orders does not matter there. Something like this is a histogram, similar to a bar graph, but this is for quantitative data like in a box plot. Responses are grouped into bins and display frequency of each response. Bin sizes are how many whole numbers are in the bin. So all three of these histograms are the same data, but they have different bin sizes. We can see, looking at that range from 50 to 60, they're a 10 range of 10. The middle one is a range of 5. It looks like that last one, I think, is a range of 2, if I'm not mistaken. So same data, but just different bin sizes. The first one we see 4 bins, we see 4 bars, right? The second one, 6 bins, 6 bars. And then 12 bins, 12 bars. So our frequency types, those are the y-axis, frequency or quantitative frequency. This is the amount of people or a head count. And our relative frequency is, like we've talked about before, it's a sample percentage from the total amount. So when we describe shape of a histogram, this will be important, especially in this next unit that we start after this one, which is solely over the normal distribution. Our shape of a histogram is fairly symmetric. Not everything is perfect, but this is where our mean approximately equals the median. So I'll show you here in a second. Heights of people, that would be something that is normally just a normal distribution. And I've already created these histograms that you'll see a relatively symmetric look, like a bell shape. And then left versus right skew. These are both histograms. Left skewed and right skewed. And how you can kind of remember this is if you look at your feet, like your left foot, how you have your big toe on the right, and then your toes kind of go down and get smaller, and your foot kind of goes down towards the left. That would be left skewed, and right is the same. When we have something that's left, our median is skewed left. Our median is more than our mean, and if we have something that's skewed right, our mean is more than our median. So we're going to construct a histogram real quick, and I'm also going to show you how to do this in Google Sheets for a second, but we'll do this one by hand first. So I have all of these different data values, and I'm going to kind of count them up because I need to figure out my frequency. So if I look at this list, I have 2 2s, I have 5 3s, 3 4s, 2 5s, 1 6, 1 7, and 1 8. So I'm going to make my X and Y axis. My frequency is going to be on my Y axis, and I'm going to put my actual numbers in numerical order on my X axis that are from my data set. And then from here, I'm just going to count them up. How many did I say I had? So I'm going to label this. The largest one I have is I have 5 3s. So I'm going to go at least up until 5. I gave myself an extra number just so I can see the top of it. And then I'm just going to draw a bar, a bin. I'm going to go up, since I have 2 2s. I'm going to make a little bin, and histograms do touch. So we're going to make these touch each other. I have 5 3s. My 4s, it says I have 3 of them, so I'm going to go up to my frequency of 3. And these should be relatively the same size. Mine looked like my 3s are fatter. That was by accident. I have 2 5s, I have 1 6, I have 1 7, and I have 1 8. And I get something like this. And then I would ask you, like, how would we say that this is skewed? And if you think about your feet, this is not symmetric, right? This is kind of going up like your right foot would be. Like you would have your toes, I guess. You have this big toe, right? And then you have this one that may or may not stick up. And then your other toes, kind of your pinky toe, does something like that. Every year I have people that argue this, and I think those people just have messed up feet. I don't know, but that's what you can do. Look at your feet. So this would be considered skewed right. What does this tell us about the relationship with the mean and the median? Based off of what we just got done talking about, the median in this case for this data would be less than the mean. And if we plug this into our practice sheet, we should be able to see that those numbers, the median is less. So once we plug this in, confirm the mean and median values, we're going to highlight the data range and click Insert Chart and Chart Type to create a histogram for this. And then click on the histogram menu. We're going to change the bucket size from auto to 1. So this is just like we did pie chart and everything else. And this should actually probably pop up with a histogram as recommended. This should have the same shape that we made when we made it by hand. And we're going to format our histogram to make it look pretty. I don't have an image of mine, but y'all need to do that. This is going to be part of your project, getting used to plugging this in. So here's my box plot for the same set of data, my 5-number summary. And I do think I have this in here. And in my 5-number summary, my mean is 4.1, my median is 4. So not a huge difference, but it's still skewed right. I also don't have very many data values. So here's my histogram along with my box plot. We can kind of see how they kind of line up. We have that little tail end from that Q3 to that max, just like we do on the histogram. The line is looks like it's almost in the center of that box, but our mean and our median were relatively kind of close. This is a kind of what the histogram and box plots looks like when we compare the same type of data, what a left skewed and right skewed and symmetric look like. So notice the median line in the box and how that compares to the rest of the box, like whether it's on the left or on the right. And when it's on the left, when the line is on the left side of the box, remember that's right skewed. If it's on the right side of the box, that would be considered left skewed. So look at your feet when in doubt. So create a histogram of heights in Google Sheets. We're going to format our histogram and make it look professional. So we just talked about how to do that. And then what is the shape of our histogram? What does the shape tell us about the mean and the median relationship-wise? These are all of the histograms for both the boys, the girls, and everybody together. And if we notice, they are approximately symmetric, and they should be. They're kind of bell shape, but they are approximately symmetric. These are not left skewed or right skewed. We can compare the means and medians, and yeah, they're maybe a little bit off, but we also had, I think, 120 different data values for this. So it came out pretty nice on this, but we can compare, for instance, our median with our mean. I mean, 0.1 difference, 0.4 difference, 0.3 difference for this last one, and then look at the shape itself, right? So you should only be doing one of those. Looking at this example, just kind of going back to describing shape, how do we describe the shape of this? We've got that little kind of peak end between 1 and 2 hours with relative frequency at 20%. We've got that tail that kind of flattens out and then goes down. That would look like right skewed, like your right foot. Slightly skewed right, if we want to say that. So these two box plots, we're going to talk about that again, kind of comparing to, like we did yesterday, compare the weights of dogs based on their intake type at a local shelter. So the one on the top, owners surrendered, and then the one on the bottom is where they came in as strays. So this is their weight in pounds when they were brought in. What is the shape of the distribution for dogs surrendered by owners? Well, we can see that median line is kind of to the left of the middle. So this would be considered skewed right. And then how does the dogs compare for, how's the weight compare for dogs surrendered by their owners and stray dogs? Well, it looks like they're substantially less. I mean, our IQR is between like 31 and 41. So half of our dogs that came in as strays were 10 pounds, 10 to 15 pounds less on average, right? The owner surrendered. It was somewhere between that middle 50% of the dogs that were brought in by their owners were about 37 to like 54 pounds. Compare that to the other that were brought in as strays. So dogs surrendered by their owners weighed more on average, but they also had the greatest range of weights too. That's something to consider as well. Their spread was more spread out. So why do we care about the shape? The shape of a histogram or distribution can help you determine which measure of center to use. So like when we talked about earlier, like home prices, for an example, it's like this would be an example of home prices in a particular city or area. Think like Trophy Club. It's like you would use the median because if you average those $2 million homes and that $28 million home that may be kind of close to South Lake or whatever, but it's in the Trophy Club area, that's going to bring those. If you say average and you include that in with your $400,000, $500,000, $600,000 homes, it's going to make that. It's going to say that the average in Trophy Club is a lot more expensive than what it really is. So this would be considered skewed right. The mean is greater than in the median, and so in this case we would use the median when we're talking about average. Batting average looks kind of like this on a histogram. It's approximately symmetric. Here our mean and our median equal one another, and the mean is something that we would use to describe that center. Generally speaking, if your distribution is skewed, the median would be a good measure of center because it does ignore outliers, extremely high and low values. If it's symmetric, then that means that the mean equals the median, so either one is appropriate. However, mean is more typically used in that case. And that's all we have for this unit. I will talk about y'all's project next.